Hello, what's up, guys? Welcome to.
Hello, what's up, guys? Welcome back to my channel.
Assalamualaikum and salam sejahtera, and a very good day to our beloved lecturer, Dr. Taniza. So today's our group will be presenting about classification in vehicle coupon recommendation dataset. So we are group of 5: Mak David James, Hasbur Rahman, Nurul Syaira, me, Nurul Syamimi, and Nurul Farhana. This analysis was carried out in response to a requirement for subject ISP 565. This research will involve data processing, cleaning, and analysis of real-world dataset. It will produce some results that can be used to make decisions, which will followed by the study's objective. Our dataset we get from ICS website. So our problem statement is to identify a person will accept the coupon recommended to him in different driving scenarios. And the data information is collected via a survey on Amazon Mechanical Turk. And the survey is described different driving scenarios including the destination, current time, weather, passengers, and more. And then ask the person whether he will accept the coupon if he is the driver. So the ways to solve the problem is we do some classification that we produce and target class which are either that person can get the coupon or not. The number of instances is 12,684. Attribute is 24 including the class, and the type of dataset is mixed, which is consists of numeric and so this is the proof that we have the mixed data type. And then we also have some missing value. So as you guys can see in the car attribute, we have missing value. So this shows the attribute information. We have destination, passenger, weather, temperature, time, coupon, expiration, gender, age, marital status, has children, education, occupation, income, bar, coffee house, carry away, restaurant less than 20, restaurant 20 to 50, two coupon greater than 50 minutes, two coupon greater than 25 minutes, direction same, and direction opposite. Next, this data conversion will be explained by Farhana.
Okay, thank you, Shamimi. So we do a data conversion for variable expiration and age because we found that in Weka, both of the attribute are in a string format, as you can see in the left side of the image, which is the before. And then we change it to numeric format using Microsoft Excel because Weka only involve two types of attribute, which are numeric and nominal. So you can see on the right side is the after the data convention of for both attribute. And next we do the selection and cleaning process. First we identify the missing value, outliers, and extreme values. Next slide. So we found that attribute car has the missing value of percentage of 99%, which means that most of the record are empty. So we replace the missing value of attribute car using the replace missing values filter in Weka. But eventually we decided to remove attribute car because there is no use for this dataset because the missing value is too big. Next slide. We also found that there are no outliers value, but 4,235 extreme value in the dataset. Next slide. There. And next slide. So we remove the extreme value using the remove with value filter in Weka. This is the after we remove the extreme value. Okay, we also remove some unnecessary attributes such as the two coupon GEQ5 main attribute that has no unique value and has a distinct value of 1 only. So total of unnecessary attributes that we remove are 6 attributes, which all of it has the same case with 2 coupon GEQ5 mean attribute. So after we finish doing the selection and cleaning process, we save the file as the clean dataset. So the next is transformation, presented by Nurul Shakira.
Okay, thank you, Farhana. So next is data preparation for data transformation technique. So here is the 3 steps that we perform. So for this data set, we use discretization for edge attributes using 3 bins. So why we implement and perform discretization techniques on these attributes is because classification method cannot use numeric attributes if to get a better results or produce a comprehensible model. So to get an easy implementation for the next process, we use discretization to transform from numeric attributes to nominal attributes. So here it can be seen that the data for the each of the attribute have been discriminated into 3 classes. So from here we notice the value of the label is in the range value. So we exchange the value range with the value teenagers, adults, and senior citizens. So here in this slide, we attach sample of dataset that shows some of dataset after we change the range value, and then we save the file as vehicle coupon process. So I pass to the next presenter.
Thank you, Nashaira. In this session, I'm going to talk about the model development. So the model development was tested and evaluated using J48 cross validation and percentage splits using full dataset and reduced dataset, which is the dataset was reduced to 15 attributes. So for the model development using J48.3 using cross validation, we split it the testing into 2 parts, which is 10 folds and using 20 folds. These are the result that obtained using J48 10-fold for non-reduced dataset. The next one is the result using J48 320-fold. These are the result that was obtained. Next is model development and evaluation for non-reduced dataset using J48.3 using 70-30 split. These are the result that was obtained from the test. Next is the result that was obtained from the test using J48.3 using percentage splits of 80 to 20. The next one will be talk about is the model development when tested using 15 attributes. These are the 15 attribute tested using cross-validation of 10 folds. The next one is the result using 15 attributes using 20 folds of cross-validation. The next one is the result of percentage split using 70 to 30. And the last one is the result for using percentage split using 80 and 20. These are the visualized tree from each experiment. So the next one is the accuracy graph. From the result that was obtained from the J48 model test, we can calculate the accuracy for full dataset and non-reduced dataset. As we can see, full dataset achieve lower accuracy compared to the reduced dataset. So the next one, I will pass to Mark David to explain the visualization of tree.
Thank you, Hasbur, for the explanation. Could you move back to the visualization of trees? So from here, as you can see, the trees from here to make a decision from this tree is quite hard to make a decision due to the tree being so packed with information like this. But another way to visualize the tree is using a prefuse tree. So I would like to present my screen now. So can everyone see my screen?
Yes.
So this is a prefuse tree where it simplifies the tree that we had previously. So for this purpose of demonstration, I will be presenting the tree with a reduced attribute to 15 attributes and classify it using cross-validation of 10 folds. This will result us to the best accuracy. So from here, I can open here this and then go to plugin and open prefuse tree, which I have already done. So compared to the regular visualization of trees, here we can see the rules that can be made to make a decision whether or not a person will accept of the coupon. So example, here we can see the destinations, the mode of on how they take out their meal, do they like to carry out or take away, and the destination. So let's take example for coffee house. So we can click on here and it will display the frequency if the person goes to the coffee house frequency. Let's say we choose 4 to 8 times a week, and you can say that if the expiration date of the coupon is less than 2, this one is for 2 hours, then the person would, and they will ask for the time for where they go to the coffee house. Let's say we go there for 10 a.m. 10 a.m. The coupon is usually accepted by the customer. So this is how we can make a decision based on a prefuse tree rather than using the regular method of using the visualization tree. It's very hard for us to see the result of the classification. So I think that is all from me for my prefuse tree presentation. So in conclusion, based on the model development findings, we can say that there is no difference between the accuracy entire dataset using J48 cross-validation for 10 folds and also 20 folds. In contrast to 80-20 percentage split, employing a percentage split of 70-30 yields superior accuracy. On the other hand, 20-fold cross-validation produced greater accuracy than 10 folds when the dataset was shrunk to 15 attributes, as opposed to the percentage split, which used 70-30 split. 80-20 split produce superior accuracy. For overall accuracy result, using reduced dataset to 15 attribute, achieve higher accuracy compared to the full dataset. As a result of the data visualization, it produced the result of whether the person can get the coupon or not. In a nutshell, this model facilitates the decision making of a person getting the coupon. That is all from us, and thank you.